Before we talk about how knowledge organization influences students' learning, let's talk about what knowledge organization is. As Ambrose et al. Explain, people naturally make associations based on patterns that they experience, and these associations build up over time. For example, we come to understand that flipping a light switch causes a light to turn on, or that there is a conceptual relationship between ideas that share meaning, such as fairness and equality. Eventually, as we build these associations, larger and more complex structures emerge that reflect how entire bodies of knowledge are organized in a person's mind. A rich knowledge structure for a particular topic allows you to retrieve your knowledge about that topic more efficiently. As an expert in your field, it is important to remember that the complexity of the knowledge structure you have about your discipline is a lot different from the one that your students, who are relative novices, have. Let's describe what we mean by expert and novice learners. An expert learner is someone who knows a lot about a discipline, as well as how the discipline is organized. As an established scholar in your discipline, you are an expert learner. You have a rich, meaningful knowledge structure of your discipline, so you are able to recall your current knowledge and to learn new disciplinary knowledge efficiently. A novice learner is someone who has just started learning about a particular discipline. Your students are novice learners. Your students have not yet developed a meaningful knowledge structure in your discipline, so they must spend more cognitive effort to recall and to learn knowledge. There are two main ways that expert learners organize their knowledge differently from novice learners. We'll discuss these differences on the next few slides. First, experts organize knowledge in dense, interconnected hierarchical structures, whereas novices don't yet have the experience to develop these dense interconnections. As a result, a novice's knowledge structure is sparse and disconnected, and they will have a difficult time drawing meaningful connections between different ideas without help. For example, an art history professor might present works of art in chronological order, but expects that students will also notice similarities between key features of different artworks. The two paintings on the right were created in different centuries, but both artists used a similar technique called chiaroscuro. In this technique, strong contrast between light and dark is used to model three-dimensional forms. Unless the professor highlights such similarities explicitly, her students may struggle to draw these connections or even notice that there are connections to draw in the first place. The second way that experts differ from novices is that experts build new knowledge on top of deep theoretical foundations, whereas novices may only see the superficial aspects of new knowledge because they don't yet have a firm theoretical foundation to connect that new knowledge to. For example, physics experts would recognize that the sketches on the right represent problems that can be solved using the principle of conservation of energy. However, novices would classify them as different types of problems because they look so different. Novices would classify the first sketch as an inclined plane problem and the second as a spring displacement problem. Unless the connection to conservation of energy is explicitly highlighted, students will have a difficult time recognizing that the same fundamental theory governs the solution to both problems. So now that we've talked about knowledge organization and about differences in how experts and novices organize knowledge, we want to ask ourselves how we can apply this principle to improve student learning. Here are a few strategies that can help. You can explicitly share the organization of the lecture, lab, or discussion. Explicitly highlight deep features of the material. Make connections among concepts explicit. Ask students to draw a concept map to expose how they organize their knowledge. And prepare assessments that match how the material is organized and presented. How has the principle of knowledge organization helped you understand your students and their learning? We asked this question of a group of educators. In their responses, you'll hear references to some of the strategies we just mentioned, and you'll hear other strategies as well.